Hi everyone. So in this slide, we are going to complete the 10th class, CBSE 10th class science chapter. That is the 12th chapter, that is electricity. This chapter we are going to complete in the two slides. Okay. So first we will complete one slide. We'll complete up to the resistance connected in the series and parallel connection. Up to that part we'll complete. In the next slide we'll complete the heating effect of electric current. So that we'll see in the one slide. Okay. Now, shall we start now? So this topic is very important for term 2 examination of science. Okay, under the physics part. Okay, so if you see here, under this topic, first I'll give a just outline map of the total chapter. So under this chapter, just we are going to learn about the electric current. Electric current. So already we know what is called as electric current. Okay. So electric current we can call as a flow of charges through the conductor. Okay. So what do you mean by electric current? The flow of electric charges through a conductor. Okay. The electric charges here, what are electrons are the electric charges. Okay. The flow of electrons in a conductor. So mostly here we took only metallic conductors. That way, that metallic conductors we are talking about totally under this chapter is metallic conductors. Metallic conductors. Okay. So that's why the charges we consider as electrons. Suppose if you talk about the electrolyte now the conductors of liquid conductors. Generally we can call it the liquid conductors. Okay. Now that in that case that is different. Okay. In the case of electrolytes, okay, the charges we can consider as ions. Okay. Now here purely we are talking about the metallic conductor. That's why we are talking about the electrons. Okay. The rate of flow of electric charges in a conductor we can consider as a electric current. Okay. So this electric current, what is the unit of electric current? That is ampere. Okay. Ampere, a symbol is A. A is the symbol of ampere. Okay. So with the help of A is the unit of SI unit of the electric current. Okay. And how mathematically we can express the electric current. So electric current we can express in terms of charge per unit time. Charge per, so where Q is the charge per time. Okay. So what is the Q here? Q is the charge here. Q is the electrical charge, and T is the time. Okay. So by mathematically we can able to find the electric current by using these two terms. If you know the charge and if you know the time of flow of charge, we can able to find the electric current. And so where Q charge equal to N into G. N into E. Okay, wherein is the number of electrons, where E is the charge of electron, wherein is the number of electrons, and where E is the charge of electron, charge of electron. Okay, so we'll see one by one in later in the next step. Okay, and how experimentally we can able to find the current here, just by using the instrument called as a ammeter. Okay, so with the help of the ammeter, so we can able to find experimentally the flow of electric charges through a conductor. So only we can call as the electric current. Okay, now how this ammeter is connected to the circuit? So always this ammeter is connected in the series to the circuit. Okay, where we want to find the suppose we want to find the electric current in the circuit. To the circuit, always you have to connect in a series connection. Okay. Now, next. So what do you mean by electric circuit? So already we learned electric circuit is a continuous and closed path of a electric current. It is a continuous and a closed path of a electric current we can call as a electric circuit. Okay. Now, in the electric circuit, the direction of current. Okay. So in the electric circuit, suppose if you take, I will write one electric circuit. So in electric circuit, always the current will move from from a positive terminal of the cell to the negative terminal of the cell. Okay. For example, so I will construct one cell here. with the cell. Okay, and this cell is connected to the bulb here. Okay, and this is connected to the ammeter here. This is the ammeter, and is connected to the. Okay, now this is a simple electric circuit. Okay, and here we have a. Okay, so here we have a one plug key. Here we have one key. Okay, here we have one key. Okay, now key is closed here. Okay, now the positive and the negative terminal. Okay, so current always will start from the positive terminal of the cell and reach to the negative terminal. Okay, the direction of current. Okay, and what is the direction of electron? Electrons are always opposite they will travel. So electrons will travel always in opposite direction of the current. Okay, so that we have to keep in mind. So in an electric circuit, the current always flows from the positive terminal to the negative terminal of the cell. Okay, now, and always you have to connect the ammeter parallel to the circuit. Now, so this is the basic things about that what we are going to learn in details up from this chapter. Okay, next. So first we learn what is called electric current. So unit of electric current, and so we can find electric current mathematically by the formula I equal to Q by T. By using this small formula, we can able to find. Okay, and definitely can find by the use of ammeter. Okay, now, and this ammeter always we need to connect in the series to the circuit. And next we learn what we call as electric circuit. Circuit is a continuous and closed path of electric current. Okay, and in the circuit, the current always will flow from a positive terminal of the cell to the negative terminal. Okay, now, so always move from a positive to negative terminal. Now, so next we'll learn some important terms here under the electricity. Okay, first we need to go with what we call a charge. Charge is the fundamental particle of the atom. Okay, the charge may be either positive or negative. Okay, and we know this, like charges, that means positive charges. So they will repel each other. Negative charges repel each other. Okay, unlike charges, that means positive, negative attract each other. So this is the basic property of the charges. Okay, like charges repels, unlike charges attract each other. Okay, next. So Coulomb. So Coulomb is the unit of the SI unit of the charge. Okay, Coulomb either, and we will represent it in terms of C. See the symbol. Okay, so 1 coulomb of charge equal to, so 1 coulomb of charge. Okay, the 1 coulomb of charge equal to the charge of, so this many electrons. Now keep in mind, 1 coulomb of charge equal to the charge of 1 coulomb of charge equal to the charge of 6 into 10 to the power of 18 electrons charge. 18 electron charge. Okay, keep in mind the charge of 1 coulomb. 1 coulomb charge equal to 1 coulomb charge equal to the charge of 6 into 10 to the power of 18 electrons charge. Okay, we know well electron will carry a negative charge, and charge of electron is 1.6 into 10 to the power of minus 19 coulomb. Okay, that means the charge of 1 coulomb charge is equal to 6 into 10 to the power of 18 into 1.6 into 10 to the power of minus 19. Okay, this is the total charge of 1 coulomb. Charge of 1 coulomb. So that's why. So always we'll find charge in terms of the small formula. Okay, charge equal to N into E, wherein the number of electrons, where N is the number of electrons, and E is the charge of electron, Okay, this is about the small information about that. Sometimes they will ask questions. Okay, for example, they'll give the N value. Okay, they'll give the N value, and they'll give the Q value, and they'll ask the, sorry, maximum they won't give it. So they'll give the number of electrons, and they give the electron charge also. Okay, they will ask the charge, amount of charge. Okay, with a simple way. Okay, sometimes they'll give they'll give the coulomb, they'll give the q value charge, and they'll ask the number of electrons in that particular charge. Okay, so this is the one we need to keep in mind. Okay, so by using this small formula, we can able to find the we can able to find the charge. Okay, the simple formula we need to remember. Okay, next, see, next, so already we know, so q equal to charge equal to NT, where q is the charge, total charge, where N is the total number of electrons, E is the charge of one electron. Charge of one electron equal to 1.6 into 10 to the power of minus 19 coulomb is the charge of one electron. Okay, now, so we learned some information about the charge. Next, current. So already we know what you call as current. The flow of charges in a conductor we can call as a current or electric current. Okay, so this current we can measure in terms of charge by time. Charge by time. So where I equal to current, so current will shown in terms of I, and Q is the charge and T is the time. Okay, now it's a simple formula to find the amount of current. If you know the Q value, if you know the time of flow of charges, then we can able to find the current. Okay, next, the SI unit of current is the SI unit of current is amperes. The SI unit of current is ampere, and you have to keep in mind 1 ampere. So when the current become 1 ampere, means if charge equal to 1 coulomb and flow of time also equal to 1 second. Okay. Suppose if 1 coulomb of charge flows through the conductor in 1 second, then current flow through the conductor is equal to 1 ampere. 1 ampere. Okay. Then there is ampere equal to, you can also express like this, ampere equal to coulomb per seconds, or like we can write like this, coulomb second inverse. Okay, next, small amount of current we can measure in terms of milliamperes and or microamperes. 1 milliampere equal to 10 to the power of minus 3 amperes. 1 microampere equal to 10 to the power of minus 6 amperes. Okay, you have to keep in mind. Okay, small amount of current we can measure in terms of milliamperes. Okay, and microamperes with the relation 1 milliampere equal to 10 to the power of minus 3 amperes, or 1 microampere equal to 10 to the power of minus 6 amperes. Okay, now, so we can measure the current by using an instrument called as ampere, ammeter. Sir. So ammeter is an instrument. Okay, so with the help of this ammeter, so mathematically we can able to find the current by using this formula, charge by time. But experimentally we can able to find, so by using this instrument called as ammeter. Okay, so in ammeter, so what, one side positive terminal, one side negative terminal. Okay, this is the symbol of ammeter. Okay, so A round, positive and negative. Okay, so in the lab, this positive is coated with the black color, terminal, and negative is coated with the red color. Okay. The black and red. Black is a positive, red is a negative. Okay, next. So ammeter has a low resistance and always connected in the series connection. Okay, so to suppose you want to find the current in a circuit, always you have to connect it in the series connection. Okay, so these are keep in mind. Okay, so here we learn some information about the current, how we can able to find the current, and the symbol of ampere. So ammeter. So ammeter is one of the instrument. So we can able to find experimentally by using this ammeter, and this is the symbol of ammeter. Okay. So this ammeter have a low resistance, have very low resistance. Okay. Because by using this one we are going to find the electric current. That's why. So always we have a low resistance. Is always connected in the series. Okay. Next up. So in a circuit, the current always will flow. Current always will flow from a positive terminal of the cell to negative terminal. Positive to negative terminal. Okay. So So ampere have a low resistance, always connected in the series. Okay. Now, so if you see the direction of current, so direction of current is always opposite the direction of the electrons. Direction of electrons. Direction of electrons. Okay. That you have to keep in mind. Okay. Now, so direction of current is always opposite to the direction of electrons in a electric circuit. Okay. Next. So now, so I will draw the one simple electric circuit. I will show the direction of current and direction of electrons. Okay. So here, so already we know to construct a simple electric circuit, we required a cell and also required a plug key, and we required to measure the current. We required ammeter. Okay, and that ammeter. Next, we required electric load. Next, that is connected to the positive terminal. Okay, the negative terminal. Okay. Now, so these are the electric conductors we use for connecting the electric components. Okay, so the direction of current is always from positive. This is the direction of current. Direction of current. Okay, our direction of electron is opposite. This is the direction of current. Okay, so current will flow from positive terminal to the negative terminal. The electrons will flow from negative to positive terminal. Okay, so electrons will, so we need to go close the gate. Okay, now, so electrons will flow through the ammeter, then you reach to the load. Okay, so current will flow in opposite direction. Okay, this you have to keep in mind. Okay, now, next is about the electric current. Next we'll see the next important term, that is potential difference. Potential difference. Okay, so actually this potential difference which help us to flow the, actually this with electric potential or potential difference. This potential difference helps to flow of charges. Okay, it causes the flow of charges to the conductor. Okay, so because of the potential difference, only the charges are flowing. Okay, and who will produce this potential difference? Now the cell will produce potential difference. The cell will produce potential difference. Potential difference. Keep in mind, cell will produce potential difference. Okay, so because of potential difference in the cell, potential difference in the circuit, because of that only the electrons are flowing, the charges are flowing. Charges are flowing in the circuit. Okay, if there is no potential difference now, there is no flow of charges. If there is no flow of charges, there is no current. Okay, cell only will produce in the potential difference. Because of the difference in the potential, the electrons are flowing through the conductor. Okay, now, so this potential difference is the work done. So with the help of the potential difference, what you are doing? So it is work done to move the unit positive charge through a conductor from one point to the another point. It is the work done by the unit positive charge. Okay, to carry the electric current from one point to the other point. Okay, where the charge will do some work. Okay, it is the work done by the unit positive charge to bring charges, to bring electrons, to bring current from one point to the other point, to one point to the other point. Keep in mind, in a cell, positive terminal always at high potential, and the negative terminal at low potential. That's why, so electricity always move from a high potential to the low potential. Low potential. Okay, so from high potential to low potential, the electricity will flow. Okay, that is from positive to the negative. Okay, now we can measure, we can find the electric potential by using this simple formula. Electric potential equal to work done by the charge, work done by the unit positive charge. Okay, where W is the work, W is the work. Okay, so we can measure in terms of joules, and Q is the charge. Charge we can measure in terms of coulombs. Okay, now, so unit of Potential difference is volt. Is volt. Okay. So 1 volt equal to, suppose, if work done by the charge is 1 joule, okay, so if charge is 1 coulomb, then what about the potential difference? Equal to 1 volt. When the potential difference equal to 1 volt here, when 1 coulomb of work is done by work done in carrying the cooling charge, then potential difference equal to 1 volt. Okay, if the work equal to 1 joule, okay, and that 1 joule work is done by the 1 unit positive charge. Okay, so automatically the potential difference equal to 1 volt. Okay, simple. If the work equal to 1 joule, charge equal to 1 coulomb, now automatically the voltage, the potential difference equal to 1 volt. 1 volt. Okay, so this is about the potential difference. So keep in mind, because of the potential difference in the circuit, this will cause us for a flow of charges. Okay, now that we have to keep in mind. So already we found. So potential difference we can show it in terms of V. Potential difference equal to Q by charge. Q by charge. So work by cell. Potential difference equal to work done by the charge. Work done by the charge. Okay. Now, so the unit of potential difference is volt. Okay. So 1 volt equal to 1 joule per coulomb. Okay. So work is measured in terms of joules and charge measured in terms of coulombs. That is 1 volt equal to always 1 joule per coulomb. Okay. Now, next. So already we learned what you call as 1 volt. So when 1 coulomb of when is the potential equal to 1 volt? When is the potential difference equal to 1 volt? If 1 joule of work done is done by the 1 coulomb of charge. If one joule of work done is done by the 1 coulomb of charge, and by 1 coulomb of charge, then potential difference equal to 1 volt. 1 volt. Okay. So this potential difference you can measure in terms of voltmeter. Voltmeter. So this voltmeter is an instrument to measure potential difference. Okay. And so this voltmeter have a high resistance. It have a high resistance. Okay. And this potential difference always have to connect in the parallel. Always have to connect in the parallel, not in the series connection. You have to connect in the parallel. Okay. If you see the symbol of this voltmeter, so V, it also have 2 terminals, positive and negative terminal. Okay. Next. So this is a voltmeter. Okay. Next. So already we know cell is a simple device. Okay. So it will maintain the potential difference in the circuit. Okay. Next. So next one is current always flow from a high potential to the low potential. That means from positive terminal to the negative terminal of the cell. Okay. That we have to keep in mind. Okay. Next we'll see some important symbols of the components of the electric circuit. Okay. Now we'll see some important symbols of commonly used components in the circuit. Okay. This first one is the electric cell. So electric cell will convert chemical energy into this electric cell will convert chemical energy into electrical energy. Okay. So this this cell will help us to maintain the potential difference in the circuit. Okay. So this cell will produce potential difference. Okay. Okay. It will produces potential difference. Okay. But how it will produce the potential difference? Due to chemical action within the cell. Okay. So because of this potential difference only, the charges will flow through the circuit. Okay. Now, so the cell will show in this is the symbol of cell. Okay. So one long line is the positive terminal, short line is the negative terminal of the cell. Okay. If these cells are connected in series, we'll get a battery. Okay. How to connect the series connection. So negative terminal of the cell is connected to the positive terminal of the next cell. Positive terminal of the next cell. Okay, like this. Okay. So negative terminal of the one cell is connected to the positive terminal of the other cell. The cell 1, the cell 2. Okay. So if you connect the cells in series, you will get a battery. Okay. Next important electric component is key. Okay. The open key symbol. The open key symbol. Okay. We have other key also. The plug key. We have other key also. The open key. It also one more symbol. Switch. Either switch. Either switch. Okay. Either switch. Either key. So mostly this symbol only we use in the physics space. Okay. With a switch. Open switch. Switch is open. Okay. Next, closed key. So if you put a dot inside, there is a closed key. Then only the electricity will flow inside the circuit. Okay. Here also we can show the closed switch. This is the closed switch. Okay. Next. So wide connectors. So connector will be shown in terms of straight lines with arrow mark. Okay. Just lines. They are connected. Conducting wires. Conducting wires. Conducting wires. Okay. Next. So wires joining. Suppose you want to show the wire, two wires joining the symbol. Suppose wires crossing without joining is the symbol. Okay. So bulb will show like this. So the symbol of bulb. Next, resistance. So this is the fixed resistor. This is the symbol of fixed resistor. Fixed resistance. Okay. Variable resistors. So this is the symbol of variable resistor. Okay. So rheostat is the one of the variable resistor. We can able to vary the current. With the help of this, we can able to vary the current in the circuit. Okay. Next, ammeter. The ammeter is an instrument used to measure the amount of current in the circuit. Okay. This is the symbol of ammeter. And same way, voltmeter. Voltmeter. Okay. That is V and positive terminal, negative terminal. Okay. Either voltmeter. Okay. Ammeter used to measure the amount of current. So voltmeter is to measure the potential difference. Okay. So rheostat. With the help of the rheostat, we can able to regulate the current in the circuit. Regulate the current in the circuit. We can increase or decrease the flow of current in the circuit. Okay. So we have two types of resistors there. One is the fixed resistor. Okay. It has a fixed amount of resistance. We can able to, so with the help of fixed resistor, we can able to regulate fixed amount of current. Okay. But so with the help of rheostat, so we can vary the amount of current. Okay, either we can able increase or decreases. Okay, so these are the some important components of the electric circuit and their symbols. Next, see. Next important term, that is next important topic is Ohm's law. Okay, this is one of the important topic in this chapter. Okay, now, so actually this Ohm's law will give a relation between the potential difference and electric current in the circuit or in a conductor. Okay. So already in the previous case, we learned what is called as potential difference and what is called as electric current. Okay. This Ohm's law will give a relation between the potential difference across the 2 points of metallic conductor and current passing through the circuit. Current passing through the metallic wire. Okay. Now, just it will give a relation between the potential difference V and current I. Okay. So according to Ohm's law, potential difference across 2 points of metallic conductor is always directly proportional to the current passing through the circuit at a constant temperature. Okay. So whenever these two are directly proportional at constant temperature, if you raise the temperature, automatically so the relation will be, the ratio will be changes. Okay. At constant temperature, the potential difference across 2 points of the conductor is directly proportional to the current flowing through the circuit. Just mathematically, so V potential difference is directly proportional to the current I. Okay. To remove the proportional constant, so I introduce one proportionality constant, that is R. Okay. Here R is the proportionality constant. Proportionality constant. Okay. So R is the proportional constant. So this R we can call as the resistance. Okay. R is the resistance or proportionally constant in this equation. Okay. Where V is the potential difference, I is the, I is the current. Okay. So where R is a constant, proportionally constant, that is we can call it the resistance. Okay. This R is constant for a given metal. Okay. This is constant for given metal. Okay. If you draw a graph between the potential difference and the current, okay. If vary the current, by varying the current, automatically potential difference also varies. Okay. So if you see the ratio, if you see the ratio, always constant. If you see the ratio, potential difference by I, always you will get a constant number. The value is always constant. So that's why you will get a straight line which is passing through the origin. So this line indicates that the ratio the ratio of current by time is always constant. Is always constant. Is always constant. Okay. Now, so this is about the Ohm's law. Okay. Always will get a straight line. Next we'll go with what you call as resistance. Here we come across with one word now, resistance. Okay. So actually the resistance is the property of a metal to resist the flow of charges through it. So resistance always resists the flow of charges or flow of electrons or flow of current. Okay. So just either resist the flow of charges or flow of current. Okay. So this resistance is measured in terms of ohms with the SI unit of resistance. Okay. So already we know resistance R equal to volt potential difference by the current I. Okay. Now, if potential equal to 1 volt, if the potential equal to 1 volt and current passing through the circuit also is equal to 1 ampere, then the resistance become a 1 ohm. The resistance becomes what? The resistance become 1 ohm. Okay. So when the resistance become 1 ohm here, so when potential difference is 1 volt and current pass through them is 1 ampere, the resistance equal to 1 ohm. 1 ohm. Okay. Now, it's about the resistance. Okay. So to measure the resistance or to give the resistance, so we have some resistors are there. Okay. So we have two types of resistors are there. One is fixed resistance and one is the variable resistance. In the 10th standard, there is only one resistor there. There is a variable resistor. Okay. So variable resistance. Okay. So with the help of the rheostat, we can able to produce the variable resistance by changing the resistance. So we can able to regulate the current. Okay. So we can able to regulate the current without changing the source of voltage. Okay. So with the help of the rheostat, with the variable resistance. Okay. So with the help of that, we can able to regulate the charge. We can regulate the current without changing the source of voltage. Okay. So this is about the rheostat. So rheostat is the variable resistor. Variable. So it will produce the variable resistance. Okay. So with the help of the variable resistance, we can able to regulate the current without changing the source of voltage. Okay. So rheostat will show in terms of symbol like this. With the rheostat. Okay. With the rheostat, or we can also show like this. Okay. With the rheostat symbol. Variable resistance. Okay. Fixed resistor we can show like this. Is the fixed resistor. Is the fixed resistor. Fixed resistor. Okay. So this fixed resistor have fixed resistance. So variable resistor have a variable resistance. Variable resistance. Okay. Now, next we'll go with the factors affecting the resistance of a conductor. Resistance of a conductor. Okay. So resistance of a uniform metallic conductor always depends on the four factors. One. So resistance R. So already we know R is the resistance. Okay. So resistance R is directly proportional to the length of the conductor. Directly proportional to the length of the conductor. As the length of conductor increases, resistance also increases. Okay. Next is inversely proportional to the area of cross section of the conductor. Okay. If the area of cross section increases, resistance decreases. If the area of cross section decreases, resistance increases. Okay. reciprocal. Okay, so inverse resistance is inversely proportional to the area of cross section of the conductor. Okay, next, it will also directly proportional to the temperature. Okay, so it also directly proportional to the temperature. Okay, next, it also depends upon the nature of the material. So different material have a different resistance. Plastic have a more resistance. Okay, metal have a less resistance. Okay, so different metal have a different resistance. Okay, so from here, the resistance R is proportional to L by A, or resistance is equal to rho L by A. Okay, this is the formula to find the resistance through the conductor. Okay, if you know the resistance, if you know the length of the conductor, if you know the area of cross section of the conductor, and if you know the resist, we rho is the resistivity. We rho is the resistivity. Okay, so every metal have its own resistivity. Every metal have its own resistivity. Okay, it's a constant, it's a proportionality constant. Okay, so R is the resistivity. Okay, it's also called as specific resistance. Specific resistance. Specific resistance. Okay, so every metal have its own resistivity. Okay, keep in mind. So this resistivity do not depends upon the length of the conductor, and resistivity do not depend upon the area of cross section of the conductor, but this resistivity depends upon the temperature. Okay, every material have its own resistivity. Okay, if you know the resistivity of the material, length of the conductor, cross section area of the conductor, then we can able to find the resistance. Okay, so what is the unit of resistance? So unit of resistance is ohms. Ohms is the unit of resistance. Okay, now, so where rho is what? Rho is the resistivity. Every material have its own resistivity. Okay, so resistivity rho equal to, there is resistivity rho equal to, we write like this, that is R A by L. Okay, if you see the resistivity units, so R resistance measured in terms of ohms, so area meter squares, length is in meters, meter will get here, that is resistivity units is ohm meter. Okay, so so ohm we can also show like this, the meter. Okay, so ohm we can also show like a ohm meter. Okay, this is the symbol of ohm. Okay, so this is about the resistivity. The resistivity of the metal is always constant. It do not changes with the length of the conductor, length of the material, do not changes with the area of a material, but it will changes by the resistivity changes by the temperature. Okay, so this is about the resistivity. Now, so already we know resistivity. So resistivity, rho is the resistivity. Okay, so that is R A by L is the formula to find the resistivity. Okay, so resistivity so never changes with the area and length of the conductor, but it changes with the temperature. Okay, so the unit of resistivity is this ohm meter. Okay, so I already shown how we get ohm meter. So that is R is the ohm. Unit of resistance is ohm. So area of cross section measured in terms of meter square. Length we measure in terms of meters. Meter get 1 meter get cancelled. There is ohm meter will left. Ohm meter. Okay. Is the unit of the SI unit of the resistivity. Okay. So resistivity do not changes with the length or cross sectional area of the conductor, but it changes with the temperature. Okay. Next, the range of resistivity for metals and non-metals, metals and alloys is very less. That is 10 to the power of -8 to 10 to the power of -6 ohm meter. Is the resistivity of the metals and non-metal, very less. Okay. If you see the insulator resistivity somewhat high, is 10 to the power of 12, 10 to the power of 17 is the range of resistivity of the insulators. They have more resistance. Okay. Next, you have to keep in mind. So resistivity of the alloys is always higher than their constant metals. Okay. So You have to keep in mind resistivity of the metals is alloys have a higher than compared the metals. Next, so alloys do not oxidize at high temperature. So that's why, so this most of the alloys they use in the preparation of heating devices. In the heating devices like a electric iron boxes, heaters. So mostly they use alloys. Why? Because alloy do not oxidize at high temperatures. Okay, so they're the main reason. So metal will oxidize at high temperature. Okay, but alloys will not oxidize. That's why mostly, so to prepare electrical heating devices, mostly they use alloys. Okay, and copper and aluminum used for electrical transmission lines, and tungsten tungsten used as a filament. Tungsten is a filament. Tungsten is a filament in the bulb. Okay. So why? Because so copper have a less resistivity, very less resistivity. Aluminum have a next less resistivity. Okay. So because of that reason, they used as a electrical transmission lines. The electrical transmission lines. Okay. So this is about the resistivity. Okay. Next we'll go for a. Next we'll see the. So next. So next we are going to see the how to connect a resistors in series and what is the resultant resistance. Okay. So we know well. So every resistor have a two terminals with a positive terminal, negative terminal A and terminal B. Okay. So next is the resistance to terminal A and terminal B. So resistor 3, terminal A and terminal B. Okay. Now, if you connect terminal B of one resistor to the terminal A of the other resistor and so on. Okay, then that connection we can call as a series connection. Series connection. Okay, so this series these seriously connected resistors are connected to the cell. Okay, so to find the potential difference across these across the 2 points of a seriously connected resistors. Okay, so always we need to connect the potential voltmeter. Always need to connect in the series connection, parallel connection. Always we connect the parallel connection. So ammeter always we need to connect in the series connection. Either way to connect the series connection. Series connection. Okay. Now, so just we'll see the simple circuit for resistors in series. Okay. So in this circuit, amount of current I is flowing. I is the amount of current flowing through it. Okay. Now, so we the potential difference across the conductors, across the 2 points, any 2 points of a conductor. Okay. I amount of current is flowing. So we the potential difference across the circuit. R is the resistor. Okay. Next, see, when two or more resistors connected N to N, in arrangement we can call as a series connection. Okay. So in that case, the resultant resistance equal to R1 plus R2 plus R3. Okay. So the resultant resistance in the circuit. Okay. It is R1 plus R2 plus R3. Okay. Next, current through the each resistor is always same. Current in the each passing through each resistance always same. Okay. And I have to keep in mind equivalent resistance is always is larger than the largest individual is always suppose equivalent resistance. The equivalent resistance means resultant resistance. Okay. Equivalent resistance, that is the resultant resistance, is always larger than the largest individual resistance. For example, we have a 3. For example, R1 value is equal to 3 ohms. For example, okay, R2 value equal to to 2 ohms. R3 value equal to, so the R3, okay, the R1 value, R2 value, and R3 value equal to 1 ohm. Okay, the resultant resistance always how much equal to 6 ohm. Just we need to add up. Okay, the resultant resistance is always greater. How much here? 6 is always greater than the so largest individual resistance. Among the 3 resistance is the largest value. And compared to largest individual resistance value, so equivalent resistance value always greater. Always greater. Okay. Next is the point you have to remember. Okay. So to find the resultant resistance, just you need to add up the sorry, add up the resistance. Next, the total voltage. The total voltage always equal to sum of the voltage drops. Okay. How we got this one? Simple. Okay. Now this resultant resistance equal to already we know that is R equal to V by I. V by I. So already we know. So when the resistors connected in series, the current passing through the resistor is always same. I is same. Okay. That is resultant resistance RS equal to Vs V by I. That is V1 by I plus V2 by I plus V3 by I. Why I keeping the I here? Current is always same to the heat resistor. Okay. Then I get cancelled. Okay. Then this is the total voltage. The total voltage equal to sum of the voltages. Sum of the voltages. V1 plus V2 plus V3. Okay. Now, so finally, so we got a resultant resistance we can measure in terms of R1 plus R2 plus R3, and resultant voltage we can measure in terms of V1 plus V2 plus V3. V2 plus V3. Okay. So these are the formulas to find the resultant resistance and resultant voltage. Okay. Next we'll see the resistance in parallel connection. Resistance in parallel connection. Okay. So this is the way we need to connect the resistances. Okay. See. So all terminals A connected to the one point. All terminals B of the resistors connected to the one point. Okay. So we know well. So this is the resistor R1, the terminal A, terminal B. Next resistors R2, terminal A and terminal B. Next resistor. Okay. So these are symbol for fixed resistor. That's why we fix resistor. Okay. So resistance. Next resistor. Okay. We have a resistance R3. Okay. Terminal A and terminal B. So if all A's are connected to the one terminal and all B's are connected to terminal B. Okay. So then we can call it a in series connection. Sorry, they are connected in the parallel connection. Okay. Now, so with the setup, with the battery, with the plug key, so with the ammeter and submeter always connect in the series connection, and voltmeter always connect in the parallel. Okay. Next. So voltage across each resistor is same here. So when the resistors are connected in series, sorry, the resistors are connected in parallel, voltage across the resistor always same. Always same and equal. Same and your voltage is same. Your voltage is same. Potential is same. Okay. Now total current is equal to sum of the currents to the individual resistors. That is, in that case, I equal to I1 plus I2 plus I3. Okay. So we know I equal to V by R. Okay. Then substitute the in everywhere, substitute the I value. I equal to V by R. I1 equal to, okay. So why we keeping V here? So voltage is same. Okay. V by R1, V by R2, V by R3. So why you keep, so voltage same. In every case, voltage same. Okay. That's why you remove the, we'll cancel the voltage. The resultant resistance is equal to sum of the resistance in reciprocal. Okay, that is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is the formula to find the resistance, resultant resistance when the resistors are connected in the parallel connection. Okay, you have to keep in mind, in this case, equivalent resistance, that means resultant resistance, is always less than the value of smallest individual resistance. Okay. So this value always less than the value of the smallest individual combination. Okay. For example, so we took the R1 equal to 1 ampere, so the 1 ohm, R2 equal to 2 ohms, R3 equal to 3 ohms, R3 equal to 3 ohms. Okay. So when these resistors are connected in series, when resistors are connected in parallel, the resultant resistance always less than the smallest individual resistance, that is less than the 1 ohm. Okay, I'll show here. That is 1 by R, resultant resistance equal to 1 by 1 plus 1 by 2 plus 1 by 3. Okay, so its LCM is 6. Okay, next this here is 6 plus, so 6 plus here 3 plus 2 is equal to, so 11 by 6. Okay, so 11 by 6. Okay, this is the resultant reciprocal. Okay, next, if we reciprocate each other, there is R equal to 6 by 11. 6 by 11. That means 6 by 11 is the smallest value when compared to the smallest individual value. See here. Okay, now that you have to keep in mind. So individual resistance is always less than the, so less than the smallest resistance of the combination. Okay, so this is about the parallel resistance in the parallel connection. Okay, in the next slide, we'll go with advantage of parallel connection over the series connection. And last topic, that is heating effect of electric current, also will complete in the next slide. Thank you. Have a nice day.